Hi everybody and welcome to day 2. Today I'm going to be going over how to implement linear regression. So what we want to do is create a model that finds a pattern of the slope of our data, so we have a line of best fit. We're going to create this model using the things we learned from the last lesson, mostly the Y prediction formula, mean squared error, also known as the cost, and then the gradient of the cost, which will help us update W and B to get a nice line that looks like this in our data. Here I have some steps laid out for us to follow to implement linear regression, and these are simplified formulas for calculating the gradient. Alright, so let's start coding. First things first, import NumPy. Then we're going to want to create a class called linear regression. Initialize it with self, learning rate, and a number of iterations. And then what we'll want to do is set learning rate to 0.001 to start out, and then our number of iterations, or for how long our model will train, can be set to 1,000. Let's initialize the learning rate now. Same thing for the number of iterations. Also the weights and the bias. Alright, we're going to need 2 more functions. First one is going to be fit. It's going to take in self, our training data, as well as our training output. And then we're also going to need another function called predict that we'll use to run predictions. And this will take in some X test data. Alright, so how do we want to implement fit? Well, let's take a look at our instructions. We want to initialize a weight as 0 and bias as 0. The key thing to note about the weight though is that we need to have it set up as an NP matrix so that we can actually multiply it by X. So we can do that first off by finding the number of samples, number of features, and we're going to call this special method called shape. And what shape does is returns the number of rows and then the number of columns, which would be equivalent to the number of samples that you have, and then the number of features. Alright. Next thing we're going to want to do is initialize the weights and the biases. So like I said earlier, we want this to be weights to be a matrix. So we can call this special method zeros, and you can actually pass in the desired shape that you want. And we want it to be equivalent to the features here. And then bias can actually just be 0. Alright. Next thing we want to do is predict. So we need to predict so that we can calculate error. So this is pretty easy. We'll call Y prediction. What we're going to want to do is call np dot dot on X, and then self.weights, because we're going to be multiplying these two just like in here. Then we're just going to simply add self.bias, and this will be for the first row, but as we continue through, it'll update and iterate. Now we need to calculate the gradients, so we can do that by looking at our formula here. We have simplified versions. This is 1 over the number of samples with times where we take X times Y predicted minus Y. Okay, cool. So what we need to do, 1 over the number of samples, excuse me, times np dot dot, which will multiply and give us the sum. But here we need to be careful, and we need to do x dot t. We need to transpose t so that we need to transpose x so that we can actually multiply it times y predicted minus y. Alright, and then we can do the same thing for db. I think the formula is a little bit different though. I think we're just going to sum them. We don't actually have to multiply anything. Yeah, so it's just a sum. So we do np dot sum of y predicted minus y. Alright, cool. Now we can actually update the weights and the biases with this formula over here. Where was it now? Hey, where'd my formula go? Oh, there it is. Alright, yeah, so we're going to update it with these formulas right here. W minus learning rate times the gradient. So that minus learning rate times dw. We want to do the same thing for the bias. Key thing to note here is that, let's say I instead implemented my code like this. This would lead to an incorrect result because we're updating W, but we're not updating B at the same time. Alright, so be very careful with your implementation. Make sure that you always calculate the gradients first and then update weight and bias simultaneously. Alright, so the only thing that we're missing is that we want to do this, but not just once. We want to continuously update. So what we can say is for blank in a range, the number of times we want to train, which is the iterations. Alright, and then all I have to do is move this over. Boom, that's it. Alright, now on to predict. Let's say this is really simple. All we have to do to predict now that our model has been updated is call this whole thing down here and then return the result. Super simple. And that's linear regression in a nutshell. So you're gonna need data for your linear regression model. You can copy this boilerplate here that makes you a nice test data set, or I'll also have the code posted on GitHub. Make sure you import all your necessary libraries and also call your linear regression class, of course. So how we're gonna do this is very simple. You'll call your linear regression class. You can set it to whatever you want. I just called mine reg. You're gonna wanna fit it with the data that we have from above. You have train and test data. So right now we're training, so you're gonna wanna call xtrain and ytrain. Then from there, you're gonna wanna make predictions, right? So we call the predictions. Okay, then once that's done, here I just calculated the mean squared error using this simple little formula here. It's the same thing that we kind of did up here. This is the same exact thing. Alright, and then here we can actually test our mean squared error. So let's actually restart this and then call it just to show you how it works. Oh, you have to run them all. Alright, so we actually get a mean squared error of this. So this is our cost. It's a little high. Let's take a look at how our graph looks. Okay, so we see that our line is kind of fitting, but not exact. So what we can do to actually remedy this is make our learning rate a little faster. So before it was 0.001, now I'm gonna just make it 0.01. And then if I restart this and run them all again, we should have a line that looks like this. Hey, that works. Okay, cool. So you can see how the learning rate affects it. You can probably play around with this as well. Like, what if I made it really small and then see what happens? Your line is probably going to start to flatten out. Yeah, exactly. Okay, cool. So yeah, this will also be posted on the GitHub. So yeah, all the code you need should be there. But definitely go ahead and practice it. And for now, that's linear regression in a nutshell. Thank you guys for watching, and I'll see you for day 3.